Hello, this video is for Nova Online Math 161, and today we're looking at section 3.4, topic 2, expanding logarithms using log properties. Write the logarithm as a sum or difference of logarithms. Simplify each term as much as possible. So we have log base 3 of x squared y over 27. So let's separate these three things out, okay? So what I mean by three things is x squared is the first, y is the second, and 27 is the third thing that I see. So I'm going to separate these out, okay? So write log base 3 of the first thing, x squared. Now, log base 3 of x squared should be positive. Why? Because it's on top of the fraction, okay? Now, the y is also on top of the fraction, so it should be positive. Write down plus log base 3 y, okay? Now, the last thing, this green highlighted 27 is in the denominator, it's in the bottom of the fraction. So I am not going to put plus, but I'm going to put minus log base 3, 27. See, we just use log properties to expand it out. Well, the sum and difference, but there are a couple more things that we can do at this point, okay? Watch the first red one. Notice we have log base 3x to the second power, right? What we can do is we can bring that exponent of 2 down to the front. So we're going to bring that 2 in front of log base 3 of x. So this first term will turn into 2 log base 3 of x. Done. The orange one is done. There's nothing we can do about this orange. Log base 3 of y. Now, look at the very last one, okay? This can be evaluated. See, what they are asking, for log base 3 of 27 is this. 3 to the what power equals 27? And you see 3 to the third power is equal to 27, right? So this green underlined log base 3 of 27, we should simplify that because we know how to evaluate that. We can simplify that as just 3 because 3 to the third power equals 27. And that's where we should stop for this problem. So we've expanded out using sum and difference property. Bring down the exponents using the power property. And if there's anything that can be evaluated, then we go ahead and evaluate that. So that was the first example. Let's see if I have another one down here. Oh, yes, I have another one. All right, let's talk about this one. Let's expand this out, okay? So what I see is this 100,000 on top of the fraction. And I also see square root of x squared minus 46. So I'm going to separate this out here, okay? So first, I'll write log. Oh, that's a common log. 100,000. And that red term is positive because that 100,000 was on the numerator. But look at this square root that's in the denominator. I have to write minus log square root of x squared minus 49. All right, let's talk about these two. They're a little different. The first part, red one, we can evaluate this, okay? That's a common log. So basically, they're asking 10 to the what power is equal to 100,000. And let me count how many zeros we got. We got 1, 2, 3, 4, 5. So this is just 5. And you know, if you want to use your calculator to evaluate some of these common logs, so you can do log and 100,000, and it's going to tell you it is 5. So again, similarly to the previous one, if you can evaluate the log numerically, go ahead and simplify, okay? Now, if I'm grading your exam, I would be okay with you just leaving it as minus log square root of x squared minus 49. I think that's good. But if you want to do one more step, okay, watch, we can do this, okay? Leave that 5 alone for a second. But I want to show you how to rewrite the square root expression, especially when you're moving up to calculus, being able to convert from radical form to a rational exponent form is going to be very, very helpful when you're working on power rule. So what you're going to want to do is write this x squared minus 49 in a parenthesis, but instead of square root, okay, instead of writing it under square root, you can write this x squared minus 49 is getting raised to the 1/2 power, okay? They are the same thing. Square root of something is the same as something getting raised to the 1/2 power. If you do that, then we can use the log property one more time and bring that 1/2 down to the front. I think this is just a little extra step that we didn't really have to do, but you know, if we ever want to use as many log properties as possible, that was one way to do it. So I'll write 1/2 in the front and then write log x squared minus 49. We can see that x squared minus 49 can be simplified, but they're not going to be able to escape out of this log, so I think I'll really just stop right there. So not only that we use the log property, but in this example, I was able to talk about that very important skill that you will need in calculus, going from a radical form to a square, to fractional or rational exponent form. So just remember that if you ever see square root of x, you can write this as what? X to the 1/2 power, okay? So in this video, we went over 2 examples on expanding logarithms using log properties. I'm going to start another one where we will condense log, make them as short as possible by going the other way around, okay?